When we're graphing rational functions that are in the form f of x is equal to a polynomial divided by a polynomial, we'll find the horizontal and vertical asymptotes using these two different ideas. Vertical asymptotes occur whenever you would get an error by plugging in an x value. And how we're going to end up with errors, you can't divide by 0. So if you set your denominator equal to 0, whatever that polynomial is on the bottom, and solve, that will give you your vertical asymptotes. For your horizontal asymptote, what we're going to do is compare the degree of the top and the degree of the bottom. And one of three things is going to happen. Either the degree of the top is going to be greater than the degree of the bottom. In that case, there is no horizontal asymptote. The degree of the top is going to be less than the degree of the bottom, in which case there is a horizontal asymptote. But when that happens, it doesn't matter what the polynomials look like. The horizontal asymptote is always right on the x-axis, and the equation for that is y is equal to 0. If the degree of the top is equal to the degree of the bottom, then there's a horizontal asymptote, but that'll change depending on what the polynomials are. Your equation for that is going to be y is equal to the lead coefficient of the top divided by the lead coefficient of the bottom. Our directions are going to be to graph and label the vertical and horizontal asymptotes. We want to do both of those. Graph and label the vertical and horizontal asymptotes. And here we have g of x is equal to a polynomial divided by a polynomial, so we'll go through and use that criteria that we talked about just a minute ago. In order for you to find your vertical asymptotes, you set the bottom equal to 0 and then solve. Usually people factor these, but you can solve any method that you want. If you factor your common factor out on this one, you get x times x minus 4 is equal to 0. I now have two things multiplied together that equals 0, so I can set each one of those equal to 0, and we end up with two asymptotes, one of them at 0 and one of them at 4 for our vertical asymptotes. For your horizontal asymptotes, we want to go through and compare the degree of the top and the degree of the bottom. The degree of a polynomial is the highest power of x, so if you take a look at the top, the highest power of x would be this x to the first that we have, so the top is degree 1, and the bottom, the highest power of x we have is this x squared term here, so the bottom is degree 2. So the degree of the top is degree 1, degree of the bottom is degree 2, so in this problem the degree of the top is less than the degree of the bottom, and when that happens, we have a horizontal asymptote right on top of the x-axis at y is equal to 0. So now I'm ready to go through and create my graph. And I would start by putting in your asymptotes. So we have two vertical asymptotes. One of them is at x is equal to 0, which is right on top of the y-axis, and then one of them is at x is equal to 4. And for our horizontal, we have a horizontal right on top of our x-axis. So these vertical asymptotes that are here, they cannot be crossed. What that means is I'm going to kind of think of this like doing three separate XY tables. I'm going to have a section of our graph that's over here on the left side of the asymptote. In between the two asymptotes, I'm going to make an XY table for that, and then over on the right side. How many points do you need to put on your table? Well, that depends on which values you do. You need to have, I would say, a minimum of 2 points in each one of those three sections. Let me just focus on the one on the left. I do know that what's going to happen with our graph is out here on the far left side, our graph is going to get really close to the asymptote. I just don't know if it's a little bit above or a little bit below. And then for this section, our graph is going to either go up and get close to the vertical asymptote up here at the top, or down here at the bottom. I just don't know what that looks like. Your vertical asymptotes can never ever be crossed, but your horizontal asymptotes, they can be, so sometimes you get a weird graph where that happens, but when you get out on the ends, that does have our graph get close to those. So first, let me pick some values for this left section of the graph. Let me plug in -1. That's pretty close to the asymptote, a nice integer value, and maybe one way out here on the edge, maybe like -4, -5, something like that, and just see what we get. So if you plug those in and round those off to the nearest 1 decimal, we get -1.2 and -4, -0.1. which is a little weird because one is on one side of that horizontal asymptote and one is on the other. It does mean that this one is going to cross in between there somewhere. And I can't really tell exactly what's happening with the rest of the graph in this section. I probably would like to plug in something a little closer to the asymptote here to see if this is going to go upward or if it's going to go downward. I'm guessing it's going to go upward since this one's a little bit above, but maybe if I plugged in something close to the asymptote, that would be helpful. Let me try like -1/2. If you plug in -1/2, you get about 0.7. So yeah, that's a little bit higher. So it's probably definitely going to go upward, but you might even want to try like -0.1 and get something even closer. If you do that, you end up with about 4.6 for your Y value. So that's here. So that definitely confirms that that goes up. And then out here on the end, I do know it's going to be getting closer. You could plug in something a little bit further out here, like -8 or -10, and just see what that looks like. But I do think it's going to get really close to that asymptote out on the end, and then go up through these 2 points and be really, really close to that horizontal asymptote. So it gets really close here, but doesn't touch. Does go through somewhere in here. I could graph a few more points to make that a little more accurate, but that's a pretty reasonable sketch for that one. Okay, now I have another section of my graph here. Let me pick some points from that middle section. Looks like maybe 1 and 2 and 3 would be good values. If I do that, those are the numbers I get, so let me graph those. 1, -1, 2, -1, and then 3, -1.7. So looking at those 3 points, again, I know what kind of happens here. Either this graph is going to go upward and get close to that vertical asymptote here, or it's going to go downward and do the same thing, but on the bottom part of the graph, and then the same thing on the other side. Either this is going to go downward. I'm pretty sure this right side is going to go downward because this point is a little lower, so it looks like it's starting to go downward, but maybe it turns and goes upward. So I might want to plug in a few more values a little closer to the asymptotes again, just to kind of get an idea. Let me plug in 0.1 here. I could do like 0.5 or whatever too. Let me get really close to the asymptote here. Let me do like 3.9. So if I throw those into my calculator, I get -5.4 and -15.1. Well, -5.4, I can fit that one on the graph. So 0.1, -5.4 would be about here. So definitely going downward there. And then 3.9, -15.1 would be way down at the bottom of the graph. So this is doing something like this. It's going to go and curve downward on both sides. All right, so reasonably accurate graph so far. Now I need to just figure out what's happening on the other side here. So I'm going to pick some numbers that are bigger than 4 and plug those in so that I can do this right side of the graph. Let me plug in 5 and 8. Those are nice integer values. Tells me something pretty close to the asymptote and then kind of out on the end. 5, our y coordinate there is 1.4, and for 8, it's about 0.3. So about here, about there. I'm pretty sure this is going to get close to the asymptote here and then go upward, but again, I might want to plug in one more value here, maybe at like 4.5, just to see if this for sure goes up, or maybe it dips back down again, since that can cross the x-axis. If you plug in 4.5, you do get 2.9. So that leads me to believe that my assumption was right there, and I have a couple of values that are close enough to the asymptote where I really have a good idea about what's happening. So as you go through and you are doing these, at a minimum, I think you need 2 points in each one of the sections of your graph. So look at your vertical asymptotes. This one had 3 sections. So at a minimum, I would need to graph 2 points and show that XY table, 2 points in each one of those 3 sections.